this is a think problem. Think, it's a thing we like you to do, thinking. So, wait, what? Okay, so I'm going to set a timer, and what I want guys, 5 minutes, I want you to here are the rules. We want to try and figure out some mathematical way to create all the numbers 1 to 20 using exactly 4 fours and any math operations we want. I did 0, which is not one of the numbers we needed to calculate. I'm going to do 4 minus 4 plus 4 minus 4, it comes out to 0. So with any math operations and exactly 4 fours, how can we create any other number? So it's asking you to think. Just yeah, like if you have one, come and write it up on the board. And a number of people can write it once. I had 5 or 6 people up here first period. Go ahead, Nava. Can write all kinds of things. Okay, 4 plus 4 divided by 4 plus 4 is 1. 4 over 4 plus 4 over 4 is 2. Oh, you gotta use 4 fours. What? Gotta use exactly 4 fours.
Okay, quicker.
So,
I don't know.
this one, 4 times 4 is 16, divided by 4 is 4, plus 4 is 16. Yeah, but this is 16 divided by 4 is 4, 4 minus, this one doesn't work. It's the way you have it written? If you type it in on the calculator, 4 times 4 is 16. 16 divided by 4 is 4. So you got us 8. So that one didn't quite work. That was another way to get 8. So you said 4 times 4 divided by 4. Okay. Is there another one? You can put more than one up if you guys thought of one.
I know, but I'm just like, I can't. 4 plus 4 divided by 4. Plus 4 is 6.
You got one?
No. Because 4 plus 4.
Is number 4 right? Well, it's using a -8, so go on with no. Let's check 3. 4 times 4 is 16, minus 4 divided by 4, and we didn't need to put the parentheses, but some of you might feel more comfortable with that. That's 16 minus 1. This guy, 4 times 4 minus 4 divided by 4, the way that's written, we get a 15, not a 3. You might have meant something else, but mathematics.
It's like 4 times 4 is 16, minus 4 is 12.
Then you needed parentheses. The way you wrote it was not valid. So, guys, this is another thing. Order of operations matters. So 6. 4 plus 4 is 8. Divided by 4 gives us 2. Plus 4 is 6. I agree with that one. 4 minus 4 is 0. Plus 4 is 4. Plus 4 divided by 4. Okay. That used 5 fours though. Oh. I mean, good effort.
Can you do 4 squared?
Squared is a 2. You can do 4 to the 4th, that's not gonna help. Okay, 4 times 4 is 16, minus 4 is 12. 12 divided by 4 is now 3. With order of operations, that's now correct. This one didn't, okay. So, I agree that it comes out to the right number, but it used too many 4s. This doesn't use enough 4s. So. Anything else? Cleo, got anything? Abraham, keep it up.
Wait, let me write things through.
Okay, here's a hint. You can look at someone else's stuff. That's 8 plus 1. What if I did? Did I just take yours? If you see how someone, like, you can use their answer and be like, well, they added 1 on scratch. You need 4.
I didn't mean to, this is a time. Multiple. This
This
is multiple.
I got you. It's gonna raise the whole thing. Okay, what did you want? You wanted 4 times 4?
It was 4 times 4 plus 4, it equals 8. This is one less 4, but I can pop out.
You got it or
That
no?
doesn't have 4 fours.
We'll just put the other one like over here.
You got it or no?
He's an observer for.
Yeah.
Okay. Okay, so pretty good. There are ways to get all of them, and, there are other weird math operations. What is that? Factorial. What does factorial mean?
4 times 1 times
4 times 3 times 2 times 1.
But
And
that's not 4 fours.
no, it's not 4 4. So, and that makes 24. 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24.
Would you subtract 4 then?
So that's 24 plus 1 minus 4 just got us 21. Okay, what if I said minus 1? That gets me 19.
This equals 20.
I forgot that.
Sorry?
No.
So, some people did square root to get a 2 and then do something with that. Just trying to get you to think. And there are more ways than what's up here to get any particular number. Just want you to go through the exercise of thinking and remembering order of operations and all of that. Anyway, moving on. Today, I'd like to remind you, you have a quiz on Monday, and it's on the things in the packet 1 to 13. I have a review sheet that is not optional. I will check that on Monday. But page 21 and 22 in the packet also have some good things that are a review. And I didn't do a lot of stuff, I didn't actually do anything with Desmos with you guys. Third period when I let them go on Desmos, which means being on their computer, which Jose is already on, they started doing not math. Someone's like typing feverishly, I'm like, that's not math, you need to stop. And people got confused by Desmos, so I think we need to do a little work on Desmos before I let you loose on the worksheet with it. But without graphing this on Desmos, can you factor the equation? Like write the problem down and see if you can factor it. Just without the graphing, factor.
Gosh.
wrong, but it's back on that side. That's wrong. You just like put minus 4 I believe it does.
Yeah,
0?
okay.
Is there a hole?
No. First of all, can anyone factor it for me? Eleanor, can you come do it?
I just use it with my finger.
Yep, you just use it with your finger.
Put -4 where the X is, and it goes out to 0.
Yeah, you can't have like a number with 0.
Alright, let's see.
Okay, factored, perfect.
We have a
So-
little in-depth explanation.
We haven't looked at the graph yet. Do you guys have any idea what that visually is gonna look like? Okay, you're saying it's not allowed.
They cancel out, right?
They cancel out?
It's
Fernando?
gonna look like a straight line.
Okay, guys, yeah, look at this.
Straight horizontal.
It's not horizontal, it's gonna look like a line.
Ah.
It's gonna look like the line y equals x minus 2. Yeah.
Oh, yeah. Wait,
Can you wait just a minute? There's something wrong though. What is this? What happens when this equals 0?
Oh, a hole.
What happens at x minus equals -4? There's gonna be a hole. There's a problem child up top, problem child on the bottom, they mitigate each other. We said, you guys go fight it out in the hallway, you get out, and then the rest of the class can continue in a nice orderly manner. So numerically, analytically, that spot is gonna be a hole. As Emery was saying, if we plug in -4, I get -4 times -4 is +16. I get 0 divided by 0, which is, it could be 0, it could be infinity, it could be undefined. And today, specifically, what is it gonna equal? Well, if I removed these, it's removable, not actually removed, but if I remove them, what y value do I get when I plug in -4 to the leftovers? Cleo, what? -6. So at -4, -6, there's gonna be a hole. So if we look at Desmos, which I don't want you to bring yours up yet. If I look at x squared plus 2x minus 8 divided by x plus 4. So it looks like that straight line. And we said at -4, at -4 it's undefined. Does it look like it's going super, super close to -6? If I go just a smidgen this way, -5.98. Just a smidgen the other way, -6.04. So do you guys see what it, like that's a removable discontinuity. What was the question? So as we go to -4 from the left, it's -6. As we go to -4 from the right of the function, it's also -6. But what is going on with the function at -4 itself?
It's undefined.
Undefined, doesn't exist.
Does that make the total limit -6?
Okay? Interesting question. Jean Gideon just said, guys, does that make the total limit, which I'm gonna say this, does that mean if I don't tell you left or right, just the limit as x goes to 4, the function goes to -6, is that true? Yes. Is it continuous? No. What kind of discontinuity is this? Removable. And the justification things, which I have the exit cards to hand back to you, a lot of you messed up this part. you need to say, okay, limit, the road is coming in at -6. Over here, we're approaching -6. This one, we're approaching -6. However, the bridge got washed out. Cannot cross over. So what's on the quiz? Can you guys tell me? Cause some people are saying, so I did really well on the Delta math, is that all that's on it? And some people said, I really get the packet, is that all that's on it? Both, okay, so name some concepts that can be on the quiz.
Like limits, intervals.
Limits, Clara, what were you gonna say?
I was gonna say like showing, like arguing why it's the discontinuity with the limit.
Intervals, boundedness.
So, function properties. Alistair, can you tell me what's one of the kinds of discontinuities that we have?
Jump.
Jump, okay, so some of the discontinuities that you might need to define with limits, jump. Jesse, is there another one you remember? And, yeah,
For which one?
what, another kind of discontinuity? Infinite, good. And maybe it's not discontinuous at all. What's the other kind? Removable. So you need to be able to deal with those. So whether it was on Delta Math or in the packet, those are some ideas. What are some of the function properties that we talked about?
Domain and range.
Domain and range? Domain, is that X values or Y values? So range would be the Y values.
Will there be factoring?
Factoring might be a helpful skill. That's an algebra 1 concept that we're allowed to ask that you remember in pre-calculus. Yeah, what else? Finding max, finding a min. Are those X values, Y values, or coordinates? Y values. What is the high temperature? That's the Y value. When did the high temperature happen? That's the X value.
And behaviors.
And behaviors. And being able to say end behavior with limits.
Bounding?
Boundedness. What are the kinds of boundedness?
Above, below, and below.
Above, below, both, and not. The one you all hate, increasing and decreasing intervals. So those, you give X values, but you're looking at the Y values. When the Y is going up, what X values are the Y is going up over? Anything else? Any other properties? Kira, anything else?
I don't think so. Are there?
Like, I don't know, I'm not thinking of anything else either.
Okay.
Like, I don't know, Alva?
Left and right and behavior.
Yep. Written with limits. Oh, asymptotes? Alright,
We have to
So-
draw graphs.
you might have to graph. So, I have a review sheet for you, but I wanna look at these that don't require the calculator yet. Once students got their Chromebooks out, they stopped doing all math and did, I don't know what, yeah?
Can you go back to the previous slide?
This one?
No, that's the one. Yeah, like that slide, but like scroll down. Thank you.
What are we gonna do with this stuff?
I'm not drawing this right.
I know.
Or anything was the thing.
Take one and hand it back. I will come with extras. But can you look at the bottom on the back?
They really just gave me
Yo, Danny.
Oh, Danny.
Yep.
Did you pass?
Oh.
You got it back?
All good.
They all went back. Alright.
Did everybody get one? Okay, so,
I didn't get one.
all right. So, I want you guys to just sketch any graph that has an infinite discontinuity at x equals -3. Sketch any graph that has a jump at x equals 2. Like, show me you know what that means. And like the thing with the floors, if you have an example you want to put up, I'd love to see some options for each of these. Claire?
What's hard about it? Sounds good.
Okay. Is that adequately drawn?
Yeah.
Okay. And we have other things. Come on, come, take one. You can pick a different color, like green, red. You like red? Green. There you go, green. Louisa, any chance you'd be like good for doing a removable at 4? In your favorite color? What's your favorite color? Purple. Purple? Okay. He's just using his finger. Okay. Here, look. Trying to make it a different color, like this, so you could choose your own shape, but there you go. Kind of weird, right? You use your fingers and I can write over here while you do that, and it doesn't disrupt anything. I gotta say, I can use 5 fingers, and she's using one over there, and I didn't. Okay. I need one piece of information to go up on here. This is not wrong, but it's not right. I need what?
The 4?
I needed you to tell me where it was. So you needed some kind of itty bitty piece of a scale. All right, so there are lots of correct answers. Fernando put up this one. An infinite discontinuity at x equals -3. He drew axes, put on a scale, put in a vertical asymptote, and said, "Shwoop." He also said "shwoop" on the other side. Emmanuel, if I erased, okay, so we have this, if I erased this side and made it like that, is it still an infinite discontinuity? You shook your head and then
Yeah.
you did both things. He gave me all the answers, he gave the circular nod. Is it still infinite or not? Okay, this side says yes, I'm getting circular over there. It is still infinite. As long as one side is going wacko crazy, you're crazy. You're crazy. You might have been perfectly fine and stable and then -3 happened and then you start bouncing around the room talking about Broadway and how you're gonna go see that show. And then you just go off in a different direction.
Do you need 2 lines for it to be infinite, or like could it literally just be that one weird one?
You know, I kinda think you need 2 lines, cause then it's not discontinuous. Like, maybe
That's just like the line that continues.
I was just doing that. I didn't have to pick up my finger, so I need 2 lines. I needed the left. Louisa, here, do you guys agree?
Yes.
The only other option, like she could have put the height of this anywhere. She could have also colored in the dot. She did not have to. What, the example she had is fine. So we good with the variety? Okay, so, can you guys, yeah. Oh, what's,
I don't believe that.
hold on, there's another thing at the bottom of the back page.
Yeah, I don't get that bottom.
Okay, this is asking you to do a whole lot of stuff with the,
Oh, and then we have to do
So
that.
use
Yeah.
Desmos.
So it's just.
so, okay, if you wanna look at it, we can,
Oh, no, I was just confused because I didn't see the
it's
function
all
before.
related to this.
Okay.
So, that function at -5, it looks like I can just plug -5 in and get a number. This function at 1, oh, that I gotta look at that.
Okay.
All right, let's look at the front and check out Desmos. So I don't think everybody needs a laptop out, but if between each group, you guys could type something in? Yes, sir. You ready to pass? All right, guys, Desmos. How many of you use Desmos? You good with it? If you want to know, Emmanuel, no. If you want to know what the value of the function is at 2, you kind of put your finger on it. So at 2, it's 0.2. At 0, it's undefined. Ooh, 0, it's undefined. Looks like it's 1/3 that way, 1/3 this way, but at 0, it's undefined. Looks like what's going on at -3. It's that infinite discontinuity that Fernando drew for us earlier. So, if you have trouble typing in, or getting your finger to hit the spot, someone last period was like, oh, well, I type in x = 3 so that I can find the value more easily. So 3 and 0.166. Okay, yeah. Nope.
Should I do it on the computer?
So this gave you a graph, this like, all right, guys, this review sheet is meant for you to, like, you don't need Desmos for these first 2.
No, I'm saying for the last.
So for the last 2, like for this guy, these you don't know what they look like. It's, eventually in this class, you will be able to graph this, no issue, no calculator. You're good. For now, we're gonna let you use the crutch of Desmos. You're not gonna use Desmos on the quiz. And in general, we'll let you use one of these little four function calculators for arithmetic. That's all you're gonna get as a calculator. Yeah.
I have like my own calculator.
Yeah, okay, so today, use what you'd like. In this class, we're not gonna let you use a graphing calculator to graph, because we want you to be able to graph without it. So the point of Desmos today is to help you visualize what's going on. But I gave you the graphs of these first two. So I'm asking two things. What's happening at -3 and what's happening at 0? And Desmos actually doesn't show the whole very well. Cherry, what's going on at -3? X equals -3. An infinite discontinuity. Conchetta, what kind of thing is going on at x equals 0? A removable. Okay. Perfect. Hosea, I want you to give me limit definitions or descriptions of this. So why, what else do you need to tell me to say, I mean, she's right, it's infinite. Using limits, what do I put? As x goes to where? Where?
From the left side of -3.
Of what number?
-3.
So as we go to -3 from the left side, you're right, okay? So Emmanuel, he chose the side, so from the left side of -3, what's happening to this function? Visually, what's going on? It's going down to where? Negative infinity. Is that enough to show it's an infinite discontinuity?
Yes.
Emery saying yes? Yeah.
Would
One,
you,
one of the sides went to one of the infinities, that's all I need to do.
on the
and-
test, do you want us to do it on both sides? Or just
You
one?
don't need to. Rihanna's feeling a little more complete. She's like, you know what? I'm gonna do this and say from the right side, you know what? It's going to positive infinity. You could say it's infinite because of the green stuff, it's infinite because of the black stuff, or it's infinite because of both of them. Yes?
How would you write the end behaviors for them?
And behaviors for this one?
Yeah.
What's the left side gonna be? Okay, so we go to negative infinity. What's the height of the function?
Is it
Zero.
0, 0, 0, 0. It's flattening off that way. The right end behavior is positive infinity, and it is settling down to 0. Emma, how do I do the limits to show this is removable? Okay, what x value is the problem?
0.
Okay,
So
so,
as limit as x is going to 0.
okay, the limit is x is going to 0. From the left, from the right, from the left. Where is the function going?
Does not exist.
Well, from the left, I'm driving along, doobie-doobie-doo, the road comes up.
Then it,
Where, okay. What is the height? So this is what the Desmos was gonna help you with.
I didn't.
Okay.
It was like 0.166, right?
Oh, at 0? So I factored
Oh,
the
it's
bottom.
it says undefined.
Okay, yes, but on Desmos, if we look and creep up to, at 0, it's undefined. A little bit to the left, 0.335, 0.337, you know what? It's actually, if I reduce those x's, plugging in 0 now, 1 plus 1/3. from the left, it's going to 1/3. Does that make this a removable discontinuity?
No.
No. What else do I need to add?
As you're coming from the left, the right.
I need to also say for the right side, where's the function going on the right side?
Also.
Also 1/3. Is that enough information to say, there, it's removable?
No.
No, what else do I need, Isaac? There's one more thing. What's actually happening at 0? The open circle, so what does that mean? What about f of 0?
Yeah, it doesn't make sense.
So either f of 0, I don't have a value, or f of 0, whatever it is, it's not 1/3. Okay? So that's all the information you need to do these. And I need to hand back your exit cards from yesterday, 2 days ago, something day. So guys, continue working on the review sheet. And if you have questions about the card, let me know.
Scott.
Yep.
Oh, this is right there with one thing.
It's junk, but you didn't finish telling me why. So to be junk, you need to say we would not and the right is going to different.
Sorry, I didn't hit draw.
No, you're good. Cause I think it.
Another one of those is actually, it has an equal sign at the
I'm
front.
done. I thought
Right.
it's a junk.
Hold on. Because it has an extra 3, and the top line has like less than.
And here,
The bottom one is that big number, so check the top number. Okay, you plug
I was looking for
those
those
equations,
Oh, I am.
and only the top one is negative 2, so you're actually equal at 3. Yes. And then both actually equal at 2, so this is yes, yes. To find like the limit equation for both sides,
So it is
the
this,
actual
right? And then
f of 3 is negative 2. So that's also, all of them are the same negative 2. But 3 is negative 2, there's no whole. I mean, actually, yeah.
No, I just wanna understand the
Yeah.
process.
Yeah, these ones you have to plug into Desmos.
I, that's why I'm on.
For most of them, it's good. Yes.
So it says this is removed, right? So if this is removed, wouldn't there be?
You don't say
Well, so we talked about that earlier today. Hang on. So, we drew this one. Originally, there was no black dot, and I said, that is correct. Could she also have had it filled in somewhere not right there? Both of them are valid. So this one is removable, this is more like the Strawbridge stuff. And then with black dots somewhere else, the bridge washed downstream, it's removable. If you build the bridge in the right place, are there, like, a lot of you are, like, looking at your extra tickets and like, wait a second, so what's the question? What do you,
3 is equal to 3.
like,
The limit.
the example we just did here,
Right, is the same.
to show, guys, the hard ones that takes a lot of work where most of you messed up was showing either that it's a removable discontinuity or that the function was continuous. Both of those needed 3 pieces, and a lot of you gave 2 pieces, or on this one, some of you said f of x, which unfortunately you're saying the whole function, if you say f of x equals 1/3, you're saying the whole function is always this flat line of 1/3. You needed to say very specifically the function at that spot, not f of x, but f of 0. Either was 1/3 or was not 1/3, whatever. So continuous and removable are the difficult ones. You needed to say the left, the right, and right at that value. Yes? Okay. But guys, questions in general that I can answer to the class about?
Figure out what your actual is right.
First of all, does it look like, what, am I able to do the kindergarten test and draw? Can I?
Here.
Yeah.
That's too long. So, what you need to do for continuity? -0 equals -2.
Gideon,
Right.
you need
So
to
that's why I
say
didn't, I didn't understand.
from
Yeah.
the left,
Yeah, so correct. You would keep that for easy.
from the right,
You would keep that one. That's the exact point.
and at that.
Yeah, that's correct.
Is this all we have to study? This in the notebook?
All right, guys, hold up. In the land of breaking bad habits, I have too much experience with teachers saying, here's your review sheet, and then they write out the word review, and then they say quiz. They give you exactly the same sheet, exactly the same format, and there may or may not be different numbers on there. That is not this math class. So, the kinds of things that are on your quiz, your quiz is not gonna look exactly like this review sheet. It's not gonna look exactly like the packet. It's not gonna look exactly like Delta Math. I'm sorry, I'm creative. We want you to be able to take the concepts you've learned and apply them. I think, if you know what's going on from page 1 to 13, guys, have a seat, the bell didn't ring. Sit, please. So, as I just said here, showing removable took 3 steps. And then someone asked about the second one here, to show that it's continuous, because they checked, they did the kindergartner check. I'm able to draw the whole thing without picking up my crayon. So the limit from the left side is this guy. Is -2. The limit from the right is the bottom function. 3 minus 5 is also -2. Right now, I don't know if the drawbridge is stuck open, if the bridge has been washed away. I need to know where is the function exactly at when x is 3. Well, Gene Gideon said the equals is here. So I'm gonna go to the top value. From the left, it's -2. From the right, it's -2. At 3, it's -2. So what does that mean? It's continuous. So the exit card that you just got back, the class average was about 50%. And you're missing little details, which on the exit card is 2 points. The quiz is 20. So get it right for the quiz. It's 10 times more important.